Solving radical equations. A radical equation is an equation that has a variable in a radicand or a variable with a fractional exponent. One example, 3x or 3 plus root x equals 10. Another example, x to the 1/3 minus 12 equals 10. Remember, x to the 1/3 is just the cube root of x. Another example, the cube root of 8x plus 33 equals 10. To solve a radical equation, we're first going to isolate the radical on one side of the equation. So in this case, we just subtract 3 to isolate the root x. Then we're going to raise both sides of the equation to the same power. In this case, we'd square both sides. In this case, we'd cube both sides. After that, we have to check for extraneous solutions. Notice the word extraneous has the word extra in the front. These are extra solutions that work after we do squaring or cubing, but not in the original equation. Therefore, they're not a solution in the original equation and need to be rejected. Here's an example. 2 plus root 3x minus 2 equals 6. We're first going to subtract the 2 from both sides to isolate the radical, and then we're going to square both sides. So we've got root 3x minus 2 all squared. That's just 3x minus 2, and 4 squared is 16. Now we just have a simple linear equation. We'll go ahead and add 2 and then divide by 3. This needs to be checked to check for extraneous solutions. So we're going to take 6 and insert it everywhere there was an x in the original equation and see if it works. 4 equals 4 is a true statement, so that checks, and the answer is right. It can't be wrong. You can pause this video at any time, you can rewind, you can fast forward. The pace of the lesson is up to you. Try this problem. Alright, I would first add 6 to both sides, square both sides to get rid of the radical, and then solve the linear equation that's left. We're going to subtract 1 from both sides, divide by 5, and then check the answer. We have to check the answer to watch out for those extraneous solutions. So we put 7 everywhere there's an x. Do the calculation, we get 0 equals 0, which is a true statement. Therefore, the answer is right and it can't be wrong. Here's another example. 2 times the quantity x minus 2 to the 2/3 power equals 50. Remember, this is a radical equation because I have an x that's being raised to a fractional exponent. So let's go ahead and solve this problem. We're going to divide by 2 to start off. We've isolated this x minus 2 to the 2/3 power. We need to undo the 2/3 power. The only way to do that is to raise that to a power that turns it to 1. Well, if we raise it to the 3/2 power, 2/3 times 3/2 equals 1. We're doing the same thing on the right. We're raising that to the 3/2 power. We have to be really, really careful here. We're taking the square root of 25, which is 5, and then we're cubing it to get 125. But since we took a square root of both sides there by raising to the half power here, we've got to make sure we get the plus and minus introduced on the right side where the number, away from the variable. So we get a plus or minus 125. Again, that's because the half down here, the 2 on the bottom, means we did a square root. The square root of 25 is 5, cubed is 125. Now let's go ahead and solve for x. We'll add 2 to both sides. So x either equals 2 plus 125, which is 127, or 2 minus 125, which is negative 123. We need to check both answers independently. So put in the negative 123. Notice we get 50 equals 50, so that answer checks. And then check the 127. And again, we get 50 equals 50, so that answer checks. Both answers are good. So this equation actually has 2 solutions. You try one. Pause the video. Alright, I would divide both sides by 2, and then I need to raise this to a power that gets rid of the 3/2. Well, if we just take the reciprocal of that, 2/3, raise both sides to the 2/3 power, we should be good to go. 3/2 times 2/3 is 1, that's good. The cube root, now cube root, I don't have to worry about a plus and minus because it's not an even root, it's just the even roots, the squares, the 4s, the 6, and I need to worry about that plus and minus. Odd roots, 3s, 5s, 7s, I don't need to worry about that. So the cube root of 27 is 3, squared is 9. So I got x plus 3 equals 9, a nice simple equation. We'll just subtract 3 from both sides, and there's a 6. Let's substitute that 6 in for all the x's in the original equation and see what we get. 54 equals 54 is true, so that checks, and this answer is right. It can't be wrong. Another example here. This time we've got more than one x. We've got an x under a radical, and we've got an x over here by itself. We've still got to get this x out of the radical, and the only way to do that is to isolate the radical. So we're going to subtract 5 from both sides, and then square. Squaring both sides gives me x minus 3 on the left, x squared minus 10x plus 25 on the right. Remember, when you square x minus 5, that means you're squaring this number. You have to multiply it by itself. X minus 5 times x minus 5, which, if we FOIL it out, gives us x squared minus 10x plus 25. In this next step, I'm going to go ahead and subtract x from both sides and add 3. We can handle that, I think. Negative 10x minus an x is negative 11x, and 25 plus 3 is 28. Now we've got a factor. I've got to try to come up with two numbers that multiply to make 28 but add to make 11. Well, 7 and 4 come to mind. 7 and 4 is 28, and 7 plus 4 is 11. The signs down here are the same. That's the only way to get a positive 28, and they both have to be negative when I add them to get the negative 11. So negative 4 and negative 7 makes negative 11. Negative 4 times negative 7 makes positive 28. Therefore, x is 4 or 7. And again, we need to check both solutions independently. So inserting the 4, I get 6 equals 4, which is not true, so that doesn't check. We need to reject the 4. It doesn't work, it's extraneous. It does work in this equation, but it does not work in the original equation, so it's got to be thrown out. Let's check the 7, plug the 7 in for all the x's and evaluate. We get 7 equals 7. That is true, therefore 7 is right and it can't be wrong. You try one. Okay, hopefully you just added this second radical to both sides, and then we'll square both sides, and it's kind of like a 2-for-1 deal. We get rid of both radicals here in one move. So 3x plus 2 equals 2x plus 7. Let's subtract 2x from both sides and 2 from both sides, and we get right down to x equals 5. That needs to be checked, so we put 5 everywhere there's an x in the original problem, and 0 equals 0 is a true statement. Therefore, this answer is right. It can't be wrong. That's our learning target for the day. I'll see you in class.